So in this case, you've been told 1/3 of the air in a tank is removed with each stroke of a pump. 1/3 of the air in a tank is removed with each stroke of a pump. If the volume of the air remaining in the tank follows a geometric progression, determine the fraction of the original volume which remains after four strokes, isn't it? Then you've been told the sum of the first 10 terms of the progression. So when you're told 1/3 of the air in a tank is removed with each stroke, so it means every stroke in the pump removes 1/3 of volume. So each stroke removes 1/3 of, so it means V. So from here, this is what is remaining. Then you remove 1/3 of it, what is remaining. Meaning this your 2/3 is the common ratio of what is remaining, isn't it? Are we together? Are you seeing the way to understand a question? You don't rush. You don't rush the question. You take a deep breath and you understand the question. Then you will definitely get the right thing, isn't it? Are we together? So from there, if 1/3 of V is removed, then it implies what? Let us first of all note the unknowns in a GP. In a GP, the first term is A, isn't it? And that first term, which is A, we've been told it is the volume we can denote with V, isn't it? Are we together? Then the common ratio is 2/3. You see, you are writing 2/3 because you digested the question and you understood that it is 2/3. 1/3 is removed, 1/3 of V. This is what is removed. So if this is what is removed, 1/3 of V is removed. What is remaining? See, it is V minus 1/3 of V. You get what is remaining is 2/3 of V. So is multiplication. So the common ratio is 2/3, isn't it? So the common ratio is 2/3. After identifying the first term and the common ratio, then you can find the fraction of the original volume that remains after four strokes, isn't it? So what remains after 4 strokes? That will be, after 4 strokes, it will be which term? Anybody? Yes. Then, after 4 strokes, they are here talking about 4 strokes. What fraction of original volume remains after 4 strokes? Try to understand that question. Anyone? Yes? There? 4th term. Anybody? 3rd term? 4th term you have, 3rd term they have. It is the 5th term. After 4 strokes, you know the first term, when you make 1 stroke, the first stroke you are in the 2nd term. That is the first stroke. When you do the 2nd stroke, you are in the 3rd term. Are you understanding the question? So when they say what fraction of the original remains after 4 strokes, you must always understand the question. Otherwise, you get it wrong. When you just do 1 strokes like this, what is remaining is the 2nd term. Are you getting the way I'm digesting the question? Are you seeing that? When you do 1 stroke, you are in the 2nd. What is remaining is the 2nd term. Because the first term was V. What will remain is 2/3 times V, 2/3V. Meaning this is 1 stroke made, isn't it? So at the end of the first stroke, you have the 2nd term. So when we are talking about 4 strokes, it means they are looking for the 5th term. Because this term is for what is remaining. Are you getting that? Are we together? Yes. It's the 5th term. So the nth term of a geometric progression is given by, the nth term of a geometric progression is given by AR into n minus 1, isn't it? So after 4 strokes, implies which term? It implies the 5th term. Because after the first stroke, what is remaining is the 2nd term, isn't it? You see that? After the 2nd stroke, what is remaining is the 3rd term, isn't it? So it means we are using the common ratio of what is remaining, not what has been removed, okay? So from there you now get your 5th term is? Your 5th term is? AR raised to power n minus 1, isn't it? So there you get, you substitute your a, the first term is v. And your r, the common ratio is 2 over 3 raised to power. So what do you get? What is 2 over 3 raised to power 4? 16 over 81 v, isn't it? Are we together? Yes. So after 4 strokes, this is the fraction remaining. So all these cases of sequence and series we are handling, are you seeing that they are very unique in their own way? Meaning you must understand the question. You don't rush into answering the question. You have to digest and understand the question. Are we together? You have to understand the question. Take your time, understand the question, then you answer it appropriately. Let us see another case like that.